It's our next notes. It's going to be on compound inequalities. You can see I have some annotations in here. I'll explain those in just a minute. But so we've been looking at inequalities, and an inequality is something like here: x is greater than 5, or x is less than or equal to 3. And it really is a mathematical statement or sequence where we have these less than or equal to, or less than or equal, or greater than, or whatever. But it's some statement with those symbols in it. Okay, but it's usually just x and a number, y and a number. Here we're going to look at compound inequalities. We're going to have two of these together. So x is going to be greater than something, and x is also at the same time going to be less than something. So and you can kind of see the definition there. Consider two inequalities together. And if we look at an example of that, so here we might have v is greater than or equal to 4, and v is less than 18. The thing to remember about a compound inequality is it's only true when both inequalities are true. So for our answer, when we find it, when we plug it in, it has to work for the one where v is greater than or equal to 4 and where v is less than 18. Okay. And then what we're going to do is we're going to graph each one of these, this first one and this second one, and we're going to look for the overlap. We're going to find the intersection where they overlap, and that's where it's going to make that inequality true, both of them. So if we look at an example, here we have x is greater than or equal to 3, and x is less than 7. So here we just graph the first one, right? Here's the first one. X is greater than or equal to 3. We fill in the 3. We go to the right because it's greater than, and there's graph number 1. Then we look at graph number 2. We set it up the same. And here, x is less than 7. We start at 7. We don't fill it in because it's not equal to 7. It's less than 7. And we go to the left. And we look at the graph, and you see I kind of have the lines in there already. Where do they overlap? Where's the intersection? It's right here. We then take that intersection, we put it over here, and we have between 3 and equal to, it's greater than and equal to 3 all the way to 7. Okay, so then we can rewrite it. 3 is less than and equal to x, and x is less than 7. So that will give us our compound inequality. You've probably seen those before. So that's kind of our introduction. If we then look at another condition, so that one was where both are true. Sometimes, though, we might have a condition where they're not both necessarily true, and then we would use this little or in the statement. Okay, so here you only need one to be true. You can have multiple. You can have an answer for one that's true and not equal for the other. And then we graph them just like we did with the other ones. We would graph them, and then we would look for something called the union. We would just really take both graphs and stick them together. So here if we have this one, x is greater than 2, or x is less than equal to negative 1. So we just graph each one. We have x is greater than 2, here's that graph right here. X is less than or equal to negative 1, here's that graph. And then we just take both of them and stick them on a graph. So we have the x is greater than 2 right here. Then we have x is less than or equal to negative 1 right here. And then that's our final answer. It's called the union. Okay. We'll keep going. Let's look at an example of one of these problems. And let me cover that. So here we have an example. This is from the book. And it says a company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. It says write and graph a compound inequality that describes how tall an action figure can be. And then at the end we can say, well, is this a union, an intersection? We're going to look at that. So first of all, we have to figure out, well, what do we need? Okay. And then the things we really have to come up with and decide is the least it can be is 11.2. So then looking at x, the height, we have to say x is greater than and equal to 11.2. At the same time, it can at most can be 11.4. So x is less than or equal to 11.4. So that's our two inequalities that we will then graph. So then I already have it done. Here they are right here. First one, we just use the same type of graphs. This one is x is greater than or equal to 11.2. Right here, you fill in the dot. Here, x is less than or equal to 11.4. Do it this way, it comes to the left because it's less than. We look for the spotted overlaps right here, and then we regraph it. This is an intersection. So the final inequality is between 11.2 and 11.4. If we then wanted to graph this, or write out the inequality itself, the lowest was going to be 11.2, so we might want to write it here, 11.2, and it's less than or equal to x, that height of the action figure. And then we would say x has to be less than or equal to 11.4. And that'd be our final inequality that we could write for this one. So there's an example. So I also want to show you a union here as well. So here this is going to be more like the problems you get. Let me cover some of these up here first. So here we have this condition. It says solve this inequality. So we have an OR. So we have a negative 2m plus 7 is less than or equal to 13, or 5m plus 12 is greater than 37. So we have those two conditions. So what we're going to do is we're going to use rules of algebra. We're going to get this down to where it says m is less than or equal to something, or where m is greater than something. Okay? And let me show you the math I did. You can check it out. So then here I just divided by, or I took 7 away from each side. I end up with 6 on this side over here, and then 2m on this side. Then I divide by negative 2. And then you want to remember, since I'm dividing by negative 2, I have to change this sign. Anytime you divide or multiply by a number, you change the direction of the sign. So then it becomes m is greater than or equal to negative 3. That's our first graph. Then we go over to this one. 5m plus this is, and the first thing I'm going to do is the easiest operation. I'm going to undo the addition by minusing 12 from both sides. I end up with 5m is greater than 25. I'm then going to divide by 5, and I'm going to get m is greater than 5. Okay, and then so I'm going to then graph them. So here is my m is greater than negative 3. It's going to be right here. It's equal, greater than, equal to. So it's going to go to the right. And then here it's going to be m is greater than 5. So then don't count the 5. And then goes over this way. And then this is the union I'm going to actually add together. And you might see, look, this one is not filled in, but it overlaps. It starts right here, right? And then it just keeps going, right? So then I can just take this. I can then start from negative 3 and just go all the way to the right. Just add them together. That's a union. Okay. Sometimes you might have something in the middle that's not covered. Sometimes they might overlap. So then it just becomes this giant one going to the right. So that's an example of a union. Let me show you one more here. So here's an example of an intersection, a more complex one. So so here I might have negative 2 is less than or equal to x, minus 3 is then less than 4. Okay. So what I'm going to do is I'm going to divide this up. And this is a little bit different than what we've been looking at. So I have this middle part. I'm going to share this middle part with this over here. And then I'm going to share this middle part with this over here and solve both of them. So let me show you, if you're not sure what I mean, what I'm talking about. So on this one, just looking at this, I'm just going to circle it here. So if I'm looking at that, I end up with negative 2 is less than or equal to x minus 3. I'm just going to use what's on the left and what's on the right. I'm not going to worry about what's over here. So then I have that. And then I'm going to add 3, right, to both sides. And then I get 1 is less than or equal to x. I've done that one. This is going to be an intersection. So then I start off over here with x minus 3. That's going to be on the middle part again. And then I go with what's on the right. X minus 3 is less than 4. I add 3 to both sides, not 4, 3. And then I will get x is less than 7. Okay. Then I'm going to graph them. So, and also I want to show you, so I got the number on this side and the x on the other side. If it makes you feel uncomfortable, you can switch it. So if 1 is less than or equal to x, x is greater than or equal to 1. So then we have that one. That's how I like to do it. So then if I do this one, I'm going to start, say, x is greater than or equal to 1. So I start with 1, I go to the right because it's greater. I do the bottom one. X is less than 7. I don't circle 7, okay? And then I go to the left over here. And then I circle this one, right? And then I'm just going to do the union, okay? Where they'll both be true. And then here I have, in the end, I have starting at 1, going up to 7. And that's my intersection, not union. Okay. And that should be enough for you to start doing some of these problems. We will do some of these practice ones in class. Let me know if you have any questions, and make sure these are in your notebooks. And you should be fine for class. And we're kind of moving nice speed through this unit. And let me know if you have any questions.